So, welcome everybody to this second session of the second day of the virtual conference for GSE in the UK. This session is the IMS stream session 2H, and it is on dynamically managing aspects of your IMS Connect environment without recycling IMS Connect. Now, I know some of us should be really interested in things, how we can achieve that. That does sound a good topic. So without further ado, I'll when I introduce Divyam Bhatia, who's a product developer, but just in terms of questions, then Divyam is saying that he's happy for us to take questions during the presentation. So please unmute yourself and then ask that question, and he'd be happy to take that question during the presentation. So without further ado, just to say that like all of these sessions, they're recorded and the QR code is there for feedback, but I'll just pass you over to Divyam. So hi Divyam.
Yeah. Thanks, Tom, for the interview, for the introduction, and we would be presenting about the dynamically managing aspects of IMS Connect environment without recycling IMS Connect. So we will just, basically, I will just run you through the session. We would be first talking about how the IMS Connect, native IMS Connect functions, and what are the aspects that can be managed dynamically using the dynamic management systems. So hello, everyone. Good morning, good afternoon. I am Divyam Bhatia. I work as a I work as a product developer in BMC software. If anyone wants to connect with me, they can connect with me on LinkedIn or Outlook. I have pasted the QR codes here. You can scan it up and just connect with me for this. So we would just start off the session. Yeah, okay. So first of all, I would just like to introduce to the IMS Connect workflow, the transaction flow, how it works, and what are the different transactions that we talk about here. So let me know once everyone can see my screen. It's visible, so we can just continue with the slides.
It is visible.
Yeah, okay. So here we will see how IMS Connect receives client messages, processes them, and sends a response back to the client. The flow will always start with this 0008 event ID, which actually brings up the MPR region, the message processing region. And once that's done, the client can start sending messages to the IMS Connect socket. And then the client sends messages via TCP IP port. You can see the TCP IP port here. And it sends the messages to the IMS Connect. The IMS Connect will expect the messages in a format which says that the first 4 bytes should be the total message length, followed by the IRM request header, which you see here in the arrow. That is the IMS request message header. And then it is followed by the client's original message data segment. So here you see these two transactions, these two events. The one is 003C and the other one is 0049. So this represents 003C will represent the prepare for socket rate. And here the total message length is read and the IMS header is read. Once that's done, the rest of the message is read through the 0049 transaction ID. And then once that's done, the 003D represents the entry to the user message exit. Now, what is the function of a user message exit? It is that when the client is sending some transactions or some messages in a certain format, this user message exit actually converts it into a IMS readable format. The messages will be converted into IMS readable format. And once that's done, the IMS and the MPR can together process the message and send back the response to the client. So here you see 003D. This represents the user message exit entry. And here the message will enter the user message exit. Once that's done, we have the read function, and this is actually where the format change happens, the read function. And 003E represents that the transaction, the message has left the user message exit itself. Once that's done, this formatted transaction is actually sent to the IMS via XCF OTMA. You see here, we have mentioned the XCF OTMA. This is the coupling facility that couples the IMS Connect with the IMS. So 0041 event ID represents that message is sent to OTMA through this cross-coupling facility represented as XCF. Once that's done, everything happens in the IMS and the MPR region, the processing happens, which we will not cover here. These are internal IMS events that we will be showing in the flow. Once that's done, and once it leaves the IMS, here you see, it comes back to the IMS Connect through 0042, which is the message is received through XCF OTMA into the IMS Connect system. This event 0042 represents that. Once that's done, we would see the interchange in the event IDs. You see 003D here, but now 003D is transferred here, which says it enters the user message exit. Here we remember we had converted the client message into IMS readable format. Now we are converting actually the response to the client readable format. So you see this XMIT function, that is the transmit function, which happens inside the user message exit. And this event represents that the response has left the user message exit. And 004A represents that the response has been written to the socket. This is the socket in the IMS Connect. And once that's done, we have the response back to the client. This is how actually the whole transaction flow works. So we have the client, we have the IMS Connect, IMS MPR. The client sends transaction via TCP IP through IRM, and these event IDs actually then some internal IMS Connect processing. Once that's done, the format is changed to IMS readable format. Once the response is received, it is actually converted to the client readable format, and the response is sent back to the client. I hope we are here on the same page.
Yeah, can I just clarify something? I know the answer, but is there a header with that information on from the client to IMS Connect with, or how is that stored?
Yeah, there is a header. So
Yeah.
IRM header would be there. That's how IMS Connect will expect the messages. The first 4 bytes should be the length of the message, and then we have the IRM header, and then we have the actual message. Shall I move to the other slide?
Yeah, sure. Thanks for just clarifying, but thanks very much for that.
Yeah, thank you. And then we would be creating the, we would just be seeing how the native IMS Connect functions, how we create exits using the native IMS Connect. So in the native IMS Connect, we need to write assembler language routines to actually create custom in-house exits. And this will require for the users to be proficient in assembly language as well. And it will require significant time and effort to write and upkeep these exits. And if we have limited resources and expertise internally, writing and maintaining these exits will likely result in reduced performance or system disruptions. So this is how the native IMS Connect exits work. Now, when we are talking about the product that is the Energizer product from BMC, here what we would be doing is we would be actually creating the virtual exits through these interactive dialog boxes. So here you see we can have the virtual exit name written here, and also what the options that we want to select during the activation or during the creation of these exits can all be selected from here, and just we need to press enter and everything goes into the system and the exits are created as per the user. So essentially, the Energizer works within the IMS Connect address space, and it helps me to dynamically manage the exits, dynamically create the exits without having a prior knowledge on assembly language or anything like that. So Energizer will do everything for us.
And are there other products available to do that, just out of interest?
Yeah, there are product available. So Energizer would do it for you. So Energizer runs within the IMS Connect address space, and this is actually a screenshot from the product itself. So it's an interactive dialog box that we have, where we just need to mention the exit name and the options that are required to create these exits. These are user choice options, so you see them blank here. Users can activate message routing or return full word message length. And once that's done, they just need to process the exit and the exits are created. These are user choice exits that we are talking about. Okay, shall I move to the other slide?
Yeah, sure.
Okay, so what kind of exits can be reloaded and what are the processing options that can be reloaded without recycling the IMS Connect? That's the topic here, that without recycling or without restarting the IMS Connect, if we want to control something dynamically, what are the options that we can do? We can reload customer exits, security exits, router options, exit configurations, e-group options, IMS Connect configurations, ODBM configurations, exit names, or message IDs. These all are done through simple commands. We will just run through them one by one. So here you see we are trying to reload the customer exit, and this is the screen. And we simply go ahead with this command, reload exit type message, and my customer exits, any changes that I have made to the customer exits can be simply reloaded. Then we can reload security exits. This is done by this command, exit type security. And here we can mention the new name. This new name will be fed to this command itself. And once that's executed, we will have a reloading of the security exits. Uh, some of the Energizer's basic functionality include data store routing. So I would just like to talk about this, what is routing and how it can be done. So routing essentially redirects the message to the most suitable data store for message processing to attain the highest level of efficiency through during message processing. This is achieved in two simple ways. One is the affinity manager, which identifies and directs messages with distinct processing characteristics, and the other is load balancer, which actually helps me to predefine the weights and load balance with the load balancing method that is already given. And these work efficiently to provide the highest level of efficiency and routing during the message processing. This is whenever I make some changes to the router options, I can just simply reload it by going to this command, reload options type router, and it will simply reload everything for me, the router options, and I do not need to go ahead and restart or recycle the IMS Connect system. And then we have how we can reload the exit configurations, any changes that we make to the virtual exits or the customer exits, any message ID corrections that we make can be reloaded using this command. So here you see the command, it's reload options type exit ID.
So can I just ask if you're doing that command, and obviously that is not doing a full recycle of the IMS Connect, but presumably it is less of an overhead, and does that mean that the connection have to be re-established or what?
Essentially, in some commands, yes, the connection needs to be reestablished, but not on all the commands.
Okay.
Yeah. So if I'm making some icon changes, then the connection needs to be reestablished. But if it is not an icon change, we can just simply go ahead without reestablishing the connections.
Okay, great, thanks.
Yeah. And then the other feature is the e-group. So e-group is essentially a coupling facility that communicates between different address spaces, such as the MPR, icon, the IMS region, the IMS control region. So it simply communicates as a coupling facility. And the e-group can be used to connect between one IMS Connect with multiple data stores, two IMS Connect in the same e-groups, and multiple IMS Connect. We will just go through these briefly. So here you see, this is the e-group, and the e-group has the IMS Connect. Energizer works under IMS Connect, so hence we have used this block here. And this e-group actually helps one IMS Connect to multiple data stores. And then we have two IMS Connect in the same e-group. So here you see, this is the e-group. This IMS Connect connects with data store 1 and 2, and the IMS Connect B, that is the second IMS Connect, connects with data store 3. But these are all in the same e-group. These IMS Connects will remain in the same e-group. The third option is where we have multiple IMS Connects and multiple e-groups. So here you see, we have represented two e-groups. One is the e-group 1 and one is the e-group 2. Here the IMS Connect connects with data store 1 and 2, and the IMS Connect 2 connects with data store 3 and 4. So these e-groups can be interlinked as well, the e-group 1 and e-group 2. And to reload these e-group options, if I have made some changes to the e-group options, I can dynamically reload using this command. Reload options type e-group. And then we can reload the IMS Connect configurations using the reload options type connect command. Then we can reload the ODBM configurations in the same manner without restarting or recycling the IMS Connect. You see the command here, reload options type. And then we would talk about how the workload is being managed in the Energizer. So essentially, if I talk about say the IMS Connect, the workload management is not at the granular level. But with Energizer, the workload management can go to the governor level. So this workload manager reinforces transaction protection within the IMS system. Energizer also shields against any overloads and prevents any disruptions that may occur in an IMS system. The feature will also allow me for a precise control volume and the frequency of the messages that I receive. And effectively, it can prevent outages because I can monitor the transactions that come to the system. In cases when the designated parameters are surpassed by any messages, the tool will automatically reject messages, and this will ensure that the product simply continues to receive other messages and without any downtime. So with this workload governor, we can prevent outages that by preventing ROG applications and runaway. I'll just run through these options. So here you see the governor options. The transaction limit is set to 1000. These are transactions per second that the system can receive. It will issue a warning once the transaction load becomes 50% of the, I'm sorry, once the transaction load becomes 50% of the above limit, that is 500 transactions per second. The cycle interval here defined is 5 seconds, and low warning limit, we do not want any low warning limit. And once the limit starts to cross this 1000 transactions per second, the system will start rejecting messages. That's how granularly we can actually handle the workloads. More information can be fetched through this QR code. You can scan this QR code. There's a YouTube video on the BMC community itself. If anyone is interested, they can go ahead and have a look at that as well. Also,
can I just clarify? Is that
yeah.
the previous slide to this one? Is that part of Energizer, or is this part of the IBM setup, IMS Connect options?
This is part of Energizer.
Right. Okay. Thank you.
Yeah. Also, we can prevent any problems that happen during the message processing. We try to eliminate the problems without even occurring because we have a lot of data. So here, the screenshot that you see, this is again from a Energizer command. So you see the exit name, the rate at which the messages are being received. This is the current rate, the recent rate, and what are the peak rates that were received in this exit. Also, the number of messages, the average number of messages, the size of the messages. So we have a lot of data in the Energizer, which helps us to actually predict the problems that can occur in the system and avoid them from happening in the first place. Also, we do have a UI system for this. So to add to the capabilities of IMS Connect, we have a UI that can help analyze transaction workflow, create graphs, grids, etc., to help users better analyze and prevent problems from occurring. And also adding the capabilities to IMS Connect to handle things dynamically. So I would just run through this interface as well. You have the help panels integrated into this console. The UI also provides with detailed help section, which helps the users to get information under one package. So essentially, we do not need to go ahead and switch between screens from the mainframe screen to the IBM documentations. So it's a one roof solution kind of a thing in this console. So you see the help panels, it tells me about the how display works or how set works or how list works. These are all drop downs, and hence the reason we are selecting this help panels. You can see every information on this. One more information that I missed in the previous slide was we do have a discovery function that tells me what are the IMS connects that are active and what are the IMS connects that are not active. So this is the discovery function for this graphical interface. Also, I would just, yeah, please go ahead.
Yeah, sorry, I was just going to ask, is that graphical interface, is that available for anybody that has the Energizer license?
Yeah.
Okay, thank you.
Okay, so here you see I have added a video, but just let me run through this screen first. So we have the options. This is my icon, and we have the options for this. Then we have the execute commands. Then we have active clients, traces, and statistics. I would just run through each of the tab here, and you see the drop-down menus here. Also, you see this question mark. When you click on the question mark, you actually get this output here, the help output. Let me just start off the video first. So here you see we just need to select the drop downs. This is more of a point and shoot, and we just simply execute it. And once that's executed, we have the output of the commands shown here. Also, if the user does not choose to clear off the output, we can see the commands that have already been run, and we can still see the output. So if we are trying to analyze something, say for example, we have sent 10 transactions and we want to analyze the load, we can do it for 10 transactions, and then we decide to analyze it for 100 transactions. We can again do it and compare the output of both the commands. Also, you see the time, date and time when this command was run. If you do not want to select this drop down, we can simply go ahead and re-execute this command, and it will give me the fresh output for me. Then we have this traces. So we can fetch different kinds of traces. We can fetch the transaction trace, the event trace, the energizer command trace, the history trace, and the statistics trace. In every trace, we can select the date and time. And also we can see the output here. I would just run the video again just to make all the clarifications. So we just simply click on the trace tab, fetch trace records. I have selected transactions here. I'm selecting date and then the time. Just simply going through the menu, and I apply the changes here. Once that's done, we can see the sequence number, the client ID, the user ID, the exit name, the data store, the transaction name, and the date and time of this transaction. Once we click here, here is the IMS request message header that we were talking about, the IRM header. And then you have the IMS request message header here. Once that's done, you can see the client message here at the bottom. This is the message segment that we were talking about. So this is the message text, and this is the actual message from the client. We can see message from the client, message from IMS. Here you are. Message to the client that was sent. What are the trace records? What are the exit results? What is the data store routing here? I hope we do not have any questions here. Okay, moving
Yeah,
on. Yeah,
I've got just a quick question. It's
yeah.
probably a silly question for those who maybe don't have an Energizer, but where's the information? Where do we get all that information that we're storing historically from? Is it from the logs? Which logs are we getting it from?
Actually, I'm not an expert in the UIS side, so I would not be able to answer that. I am assuming it might be from the logs. So we have the PCH requests that this UI would be using, and these PCH requests actually process to give me the output.
Okay.
Yeah. So moving on, and this is the most prominent tab that we have, the statistics tab, because this actually gives me all the graphs, all the grids, everything here. And this actually helps me to identify system problems, prevent any rogue transactions, and proactively mitigate any potential problems that can occur in the system. So we have a video for this as well. So we are here at the statistics tab, and we can select between these options. We have the statistics tab, and here you see that we can select from exit summary, transaction summary, data store summary, routing summary, alias summary, PSP summary. There are multiple options. I would just not go to every option. I'm just selecting here exit summary. And here you see the graphs. So we have the message count, message size, and the message rate. So here is the message count. We have input messages as 100, output messages as 100. And below you can see the exit name, and on the y-axis you see the message counts. So how many messages were sent, how many reads were invoked, how many exits were invoked. And once that's done, we have the data for all, that is combined data for all the exits. Also, we can filter it through message size as well. You can see the input average was 528 here. Also, the input max was 528, minimum was 528. This is for the Java exit. And then we have the output average as 372. Also, you can filter it through message rate. So this is the peak message rate, 2.8 messages per second. And here you see the peak rate as 3. This is the combined output of all the exits. And then we just simply go to the grid options. Here you see the number of errors, the response time, the last reset date, the last reset time, peak rate, errors, what was the input message size, average, minimum, maximum output message size. And here you see the name of the exit, the origin of this message, the type, the current rate, and the input messages. You can just scroll down. You have loads and loads of information to actually help you to predict any problems and remove it at the first place. We also have this refresh option, which we can simply refresh once there are some changes that happen. And once that's refreshed, we can have the newer output here. I hope we do not have any questions in this section. Okay, now moving on. Any further information on this new interface, you have a YouTube video. It is present on the BMC community itself. People can scan it and just simply go ahead and leverage the advantages of using the new user interface. Essentially, this was created at BMC to help people who are not very well aware of mainframes and just can simply go ahead and select the UI options and run the commands. Also, if you want to run the type 1 and type 2 commands, the option is also there. You can run the Energizer commands as well. Okay, so that was it from me in the session. We can have some questions if anyone has some questions.
I've got a general question, but for an IMS API, if you're getting an amended API, then which of those commands would you recommend, or do you have to use the IMS Connect recycling to do that if you're refreshing an existing API, amending it? So could you actually use some of those options that the lesser options that you talked about?
Could you just pardon the question? I did not really get this question.
Yeah, so if you've got an application API that's changed at the IMS Connect level, then would we recommend doing lesser activities? So some of those where we're saying you can do the refreshing for certain components, can you actually get away with not doing a full recycling of the IMS Connect to introduce a new IMS API, application API, or an amended API?
Actually, the recycling actually depends on a lot of factors. So
Yeah.
firstly, we need to actually see if it requires a completely reconnection between the IMS and the IMS Connect, then maybe we would not want to go ahead doing it dynamically. But there are multiple options that help us to do this as well. There would be commands that can help us to do this as well.
Opening up the floor to, as you said, to questions. Have we got any other questions for Divyam? Has anybody want to share any experience that they've got with IMS Connect and making changes to IMS Connect clients? Or what you see as the challenges? If you just want to unmute yourself and share your shop's details, that would be good. Okay, so we don't have any other questions here on this. What I can say is, have you got the slide with the QR code, Divyam?
Yeah, for the feedback.
Yeah.
Yes.
I know we're a bit short here, so but you know, if I can't stimulate a discussion, that's fine. So I think yes, we've got the QR code for some of the documentation you've got there, and then we should have a QR code for the session in terms of feedback. That's it. So if anyone's got any questions they'd like to ask now, then they can do, or you can probably drop and give him a line. QR code is there for this session feedback, and thanks very much, everybody. It is available, as I said, to recall, so you should be able to play the session again in your own time, obviously with the log-on you've got for the GSE details. So without further ado, I'll say thanks very much, and there is another session we've got for IMS today, which is this evening, and then we've got 2 more tomorrow, so look forward to seeing some of you on some of those streams and some of those sessions we've got going. The next one is about encryption and pervasive encryption on IMS, which is at 4:30 UK time. So hopefully I'll see some of you on that session. But thanks very much all, and thanks Divyam, and have a good rest of your day, everybody. Thank you.
Thank you, Tom. Thank you all. Bye bye.